Okay, so part one, empirical formula. What is it? Sorry if there's squeaking, it's the sound of my chair. So, empirical formula, part one, what is it? Empirical formula, put simply, empirical formula is the simplest ratio of atoms in a molecule. Don't confuse it with molecular formula, we'll come on to that later on. So, simplest ratio of atoms in a molecule. So, we've got a whole bunch of different molecules here, and we're going to work out the empirical formula for each of them. So, empirical formula, the simplest ratio of atoms in a molecule. So, molecular formula is the type and number of atoms in a molecule. So, as an example, if we look at, if I give you the molecular formula, C6H6. So, that's molecular formula. So, molecular formula tells you the type and number of atoms in a molecule. So we've got C6H6, so we know there's carbon atoms and there's 6 of them, and we know there's hydrogen atoms and there's 6 of them. If I was going to draw that, we'd have carbon, carbon, carbon. Not expecting you at GCSE level to be able to put this together, but so we've got 6 carbons and each one has got hydrogen. Let's do some double bonds in there. Don't stress about those. All that we're interested in at this point, we have got 6 hydrogens and 6 carbons. That is how we build that molecule. So the molecular formula tells us 6 carbons, 6 hydrogens. But we want the empirical formula, which is the simplest ratio. So it's the ratio of carbons compared to hydrogens. And so we want the ratio of carbons compared to the ratio of hydrogens. We know there's 6 of each. So 6 to 6, and that can be simplified down and be 1 to 1. So that means our empirical formula is CH. How do we do that? And a quicker and easier way of doing that. The empirical formula is sometimes the same as the molecular formula, but we'll get to that in a minute. So let's go through and look at some examples. So we've got molecular formula over this side. And the empirical formula over here. So first one we'll look at, so we had C6H6, and we need to make this, we need to find out how to simplify this do it in a couple of steps, but one step if possible. How can we simplify this into empirical formula? So we know we're definitely going to have a C and we're definitely going to have a H. We need to know what the numbers are. So we need to find the largest number that we can divide both of these by. Pretty straightforward. The largest number for those is 6, so we can divide them both by 6. If you divide them both by 6, it means we get 1s, and scientists are lazy, we don't write the 1s. So the empirical formula is just CH. That also means if we had C7H7, well, the largest number that those can fit is 7, so we can divide them both by 7. So C7H7 has CH, or C10H10. C10H10 would be CH. So the empirical formula for each of these is the same. They are different molecules. This has got 6 carbons, that's got 7, that's got 10. They're different molecules, but they can have the same empirical formula. So let's just go through a couple other examples. So if we had C3N12, what is the largest number that can be divided by both of these? Well, it's 3. So we divide both by 3. So 3 divided by 3 is 1. So we've got 1C. And 12 divided by 3 is 4. So we've got C and 4. So if we had C8H18, what's the largest number that both of those can be divided by? It's 2. So we divide by 2, which means we get C4H9. And we can't simplify that any further. 4 and 9, you can't simplify that anymore. Because there's no number that divides both of those. So if we have P2S3, what's the largest number that we can divide both of these by? Well, it's 1. There's no number that you can divide 2 and 3 by, except for 1. And if we divide by 1, we get P2S3. So sometimes the empirical formula is exactly the same as the molecular formula because you can't simplify it anymore. So what is empirical formula? Empirical formula is the simplest ratio of atoms in a molecule. If they give you the molecular formula in any question, if you were given the molecular formula, it's just a question of simplifying it to get the empirical formula. So S8, that's a molecule, 8 sulfur atoms. How can we simplify that? What's the largest number that can divide it? Well, it's 8. So we divide it by 8 and we just get S. Or if we had C12H10O. Well, we can't, the largest number, because if there's just an O, it means there's a 1 there, remember, but scientists are lazy, so we don't draw it. What can we do with that? Well, the largest number we can divide all those by is 1. So 12 divided by 1 is 12. So we just get 10 divided by 1 is 10. 1 divided by 1 is 1. So we just get it exactly the same for that example. And so do one more. So B3, can't write today, B3N3H6. Large number that we can divide all those by is 3, so we get BNH2. 3 divided by 3, 1. 3 divided by 3, 1. 6 divided by 3, 2. So if you're given the molecular formula, that's how you work out the empirical formula. If you're given the masses of the reactants and you need to work out the empirical formula, that's where you want to see the separate video, which is how do we calculate the empirical formula.